Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 22 of the Redesign Practice Online STAAR Test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So if we were going to take a look at this particular problem and try to figure out what type of problem is this, well, look at our answer selections. A, B, C, and D all have that same format. If we were to open up our reference materials, we would not find anything that matches, right? It doesn't have anything to do with factoring, not really the properties of exponents. These aren't linear equations because we do have exponents, but they're not quadratics because quadratics all have something to the second power, right? Something squared. This has your x in that exponent position. So this is going to be something different, and it's not on your reference materials. These are all exponential functions. And so what do we know about exponential functions? We'll talk about the standard form, but as you saw, it's not on your reference material. So you need to have this already in your back pocket before you come into the STAAR test, because it's not on the reference materials. That's our standard form, y equals a times b to the x power. And so each of these kind of stand for something. So this a is always going to be your initial amount or your starting amount. So sometimes it's population growth. You could be investing money, and you're investing $50 and your interest is compounded. You could have a shirt that is on sale and it has an initial sale price, and then it decreases at a certain percentage each week until it gets sold. There's always a starting amount. That's what that A is going to be. This B term, this B position right here, is going to be either your growth rate if it's increasing, or it's going to be your decay rate if it's decreasing. So the whole point of your exponential is you're going to start with something, then it's either going to get bigger or it's going to get smaller. Now, if it's going to have a growth rate, it needs to be greater than 1. And a decay rate is going to be less than 1. Okay, so that's something we need to keep in the back of our mind. And then this x is always going to be, in these real world situations, some type of time unit. So it might be years, weeks, days, months. However, they are exponentially increasing or decreasing based on the rate. So that's what the exponential function is going to look like in its standard form. Let's apply it to this particular problem. A shipping company started with 40 employees. Okay, so look at that right there. Started with 40 employees. Started. Hopefully, you are seeing initial amount, which means this is your A term. Okay, so we could start building it right now. Instead of y, it's got f of x, so let's build it right here. Okay, f of x equals, and I've got that A term of 40. Now, look, I'm already eliminating A and C because they're getting 43, right? 43 isn't even in the problem, which isn't always an automatic no, but if we know that 40 is our initial amount, then we need to be looking at either B or D. All right, so now we need our B term. So this is going to be our growth rate or decay rate, and then we're going to take it to the x power because look, it says x years. That's our time unit. Okay, so we're looking for that B term. It says the number of employees at the shipping company increase, okay, at a rate of 7.5%. All right, so 7.5%, 7.5%. Let's turn that into a decimal so we can multiply it. Okay, that's going to turn into 0.075. Now, if I multiply 40 by 0.075, it's going to get a lot smaller. It's going to decay. We need a growth rate because it says it increases, right? So it needs to be greater than 1. So what we actually do is we actually add 1 to it. We make it 1.075. This 1 keeps the initial amount, and this 0.075 makes it increase. So it's a little bit strange, but you need to keep that 1 in there if you want it to increase. So what matches? There we go. Right? That B is going to match because that 1 is going to keep the initial amount. So answer is B.